Okay, so we're going to finish with hair notes today, and then we'll be doing labs and practices throughout the week, basically, and we'll be starting fiber next week. All right, so this is where we left off. Yes, so the life cycle of hair is shown here. Okay, you don't have to know that much about it, but I do want you to be able to recognize it if you're seeing microscope images, or if you were actually here getting to use the microscopes yourself. So if you pull out your hair and you look at the root and it looks like this, okay, or it's much thicker and has like some skin attached to it, or if it looks more rounded, thinner, so like this is basically kind of like curled up. This has a lot of stuff attached to it. This one kind of looks like it's being hollowed out. Okay, so those are kind of the way that they look. Now, what do they mean? If they're looking like this, and that is the period of growth. So like this is what it looks like when your hair is still growing, in the growing period. Then C, catagen, is when it's in the regressive stage. So it's starting to die off, it's starting to close in, but it's not fully done or anything. Most of your hair is in the growing phase for us. So this is like what most of your hair is in this growing stage. And then this is when it's kind of done growing, but it's not like ready to fall out yet. And then the telogen hair phase is the final resting stage, and hairs are easy loss. So when we get to this phase, that's when it's like really loose and you can just like pull your fingers through your hair and it just falls right out. Is in the telogen stage. And so that was talking about looking at your roots. If you pull your root out, now looking at the tips of your hair, so the bottom. So your distal tips, the appearance of the tip of the hair shaft is an important comparative characteristic. It can tell us a lot by looking at the tips of the hairs we find at a crime scene. If sufficient sample is available, it may be possible to identify the type of treatment and estimate the length of time since the last hair cutting. So that could help us track them down. Like, is a person that looks like they just cut their hair, a person who looks like it's been shaggy. So it's not only with length is like we can tell about how long it's been since they have it cut, like how fresh their hair should look. As well as possibly even tracking down where they went and got a haircut to make sure it's the right person, how they got their haircut. So if they were cut with scissors, it looks like this, like the distal tip literally has this little chunk taken out of it. And I've tested that. I've cut my hair with scissors at the bottom, like looked at it. And because of the way scissors look, they take a little chunk out at the end. If they used a razor, if they use the clippers, which is just like the tiny scissors at a hair salon, just takes a different kind of chunk out of it. And tips usually take on a rounded form after about 2 to 3 weeks. So if it looks really rounded, it means like it's been a while since they've had a haircut. And if it's getting really frayed, that it's been like a really long time since they had a haircut, that kind of thing. You can also tell what kind of dye. You could actually track back and like literally chemically analyze what color dye they have in their hair, if they have a hair dye in their hair. So that's what this is about. So treated hair, when a person chemically treats his or her hair, traces of chemicals used remain on your hair. Some of these changes are subtle and can be detected only by using a microscope. Bleaching your hair actually removes the pigment granules. You are going to get to see some pictures of bleached hair, what it looks like under a microscope. Actually looks really cool. It has an odd yellowish tint to it, but inside of the hair itself, the pigment granules that were in the cortex we talked about yesterday are literally gone. It removes them. It's like an empty shell of a hair is what it looks like when you've bleached your hair, which is why it is so damaging. That's why it's so easy, like in Frey's hair, because it's literally stripping the inside of your hair out and gives the hair a yellowish tint. It also makes the hair very brittle and can disturb the scales and the cuticles, so giving it that frayed look at the bottom. Artificial bleaching shows a sharp demarcation. So like if you had the whole strand of hair, you could like see, like this is where they bleached their hair. And this is like where it's growing out in the roots. Whereas if they were just gradually having lighter hair, like I have at the bottom, like I have lighter pieces, but that's because it's been gradually lightened by the sun. As my hair has gotten longer, it starts off being dark. And then as the sun gets it for, however long I've had this same hair years, it gets lightened by the sun. Dyeing hair changes the color of the hair shaft. So you see these different colors. An experienced forensic examiner can immediately recognize color as unnatural or not. I don't expect us to get to that level of sophistication, but if you were getting really good at analyzing hair, you'd be able to tell like that's not a normal hair color. That is definitely like that's a fake brown, it's a fake red, it's a fake blonde. In addition, the cuticle and cortex may take on the color of the dye, which normally the cuticle, which is the outside of the hair, should be transparent, should be clear. But if you've dyed it, it might stain your cuticle. So that would be kind of a bigger giveaway. If an entire hair is recovered in investigation, it is possible to estimate when the hair was last color treated based on how much root is showing. So just on average, you can kind of calculate when was the last time they dyed their hair, how much root should we be looking for in that person, and how long ago that they must have dyed it just by the amount of root. So about 1.3 centimeters, so like it's like this. Okay, so not much is how much we grow, how much your hair grows per month on average. So measuring the length of how long the root is like, okay, it's like you've had 1 month, 2 months, 3 months. Like that's how long ago they dyed their hair. So a little example problem, if we were like looking at her root, she just got a little bit of root showing. For example, if the unbleached root region just measured 2.5 centimeters, then 2.5 centimeters divided by 1.3, which is how much our hair grows per month, equals about 1.9 months that it's been since they dyed their hair, which is about 7.5 weeks. That's almost 2 months. This information can be used to identify hairs from different locations as belonging to an individual. So it just makes it like, if we didn't call that person in and they had roots in that same length, like it just gives us more credibility when we're matching the hair to be able to do stuff like this. Now for racial differences. Again, there's only 3 categories. I can't go into more detail. If you are at home and you're thinking, I'm Hispanic, what do I fall into? Generally, you fall into the Caucasoid or European hair. That's generally the same kind. It would just probably be a darker brown, but still you're going to fall into the same characteristics of a Caucasian hair. So a human hair can be associated with a particular racial group based on established models for each group. Forensic examiners differentiate between hairs of Caucasoid, Mongoloid, and Negroid. That's their names for the breakdown, all of which exhibit microscopic characteristics that distinguish one racial group from another. Now, again, if you're a mixture of races, then we're not going to be able to match your hair, probably. They might be able to tell like that you have Caucasoid ancestry, but still it's like, it's not a perfect science by any means, but they have looked at enough hairs to have like these 3 main categories. And we'll kind of break them down. So for Europeans, generally straight or wavy. So it's generally Caucasians' hair are not the super flat, because remember, the flatter the cross section is, the more curly. So normally it's either straight, so they're rounded, or they're in between. You don't usually see a lot of Caucasians' hair being like super flattened, so they're crazy curly hair. As well as small and evenly distributed pigments. So when we're actually looking at the little pigment granules, the little color sections inside the cortex, they're generally smaller pieces of pigment, and usually evenly distributed throughout their hair. Oval or round, moderate diameters, that's what I was talking about. So it's either they're round or they're in between. So not super flattened hair, but not super round either. Color may be blonde, red, brown, or black. So could be all variations of colors for Caucasians. Then Mongoloid, now that's not just Asian. Native Americans also fall into this category. Generally, their hair is very straight. So their hair is generally very round in the cross section because it's so straight. They also generally have very densely distributed pigment granules, meaning that when you look at their hair, you may not be able to see much inside of it because of how densely packed their pigment granules are. There's just so much pigment in there, it almost looks like it's one solid color. And the shaft tends to be coarse and straight, thicker cuticle generally, and they are the ones that are more likely to actually have the medulla inside, but it might be hard to see the medulla because of how much pigment is in there. Then lastly, Negroid, generally very curly, coiled hair, so their cross sections are very flattened. Okay, now I can't say this word today. Densely distributed, clumped, may differ in size and shape. So that's kind of different about their color pigmentation. Is it's not as even throughout it. It might have like clumps of pigment here and there, and the pigment granules might actually be different sizes and shapes. Go forward. And then we have animal hair versus human hair, which is way different. So if any case you read that they confused an animal hair with a human hair, which used to happen way too much, shouldn't happen. You're going to get to see those in a microscope image. Like, they don't look alike. The only one that looks like kind of like ours is dogs, are kind of close, but not really. I mean, really everything is pretty different. So human hairs differ from that of other animals. One of the more reliable ways to distinguish between a human and an animal, for one, sometimes they just look different. But two, if they look a little similar to ours, like dogs, cattle that have a little bit more similar look to the hair, what you have to do is you calculate the medullary index. Now what that is you take the length of the medulla, so literally measure this whole diameter here, measure the whole diameter of the medulla, so that's the inner core part, measure it, and divide it by the diameter of the whole hair strand. So if I was going to take this, it would be like this little, measure that, and divide it by the whole width of the hair. Measure this, the medulla, divided by the whole width of the hair. Now, when you do that, if it's 0.5 or more, when you take this number divided by this number and it equals 0.5 or more, it's an animal hair. If it's 0.33 or less, it's a human hair. Now, I know there's a gap of what's 0.33 to 0.5. It's kind of hit or miss at that point. You're kind of like, well, it could be an animal, it could be a human. It's just kind of like weird. Generally, it's going to be under 0.33 or above 0.5. Characteristics of the cuticle may be important in distinguishing between hairs of different species. So another difference is our cuticles. So the cuticle that's on the outside of the hair, the shaft that's protecting us, all the little scales. Their scales tend to look a lot different than ours, animals-wise. There's coronal, crown-like, so it looks like little crowns stacking on top of each other. Imbricate or flattened, so all the scales are flattened on top of each other, which is what ours looks like. It's flattened. And then spinious or petal-like, so looking like little flower petals all the way down. Animal hairs also show a wide variety of medulla patterns. So different types of scales. Rodents tend to look like this one. We tend to look like this one. And some animals do too. And then cats, mink, seal, a lot of other animals have this spinious one. Medullas look the most different. I would say that's the easiest one, as you can just clearly see that we look different. So this is a human. This is a dog. See how the dog is, this is the one that's like, it's kind of close. It kind of looks like ours. That's kind of similar medulla pattern. So you need to do that medullary index where their medulla should be bigger than ours. Deers, you can't even see through the medulla because the scale pattern is so thick. Then rabbits, look at that medulla. That looks totally different than our medulla. Very, very different. Cat, very, very different. Mouse, very, very different. So they look different. Microscopy. Hair used for forensic investigations is studied both microscopically and microscopically. So macro means you just look at it. Okay, so length, color, curliness, those are all macroscopic. Then microscopic means you use a microscope. So include the pattern of the inside of the medulla, the pigmentation of the cortex, all the little pigment dots, types of scales. So that's using a microscope, not using a microscope, kind of obvious. There are different types of microscopes can really help us. There's a comparison microscope where you can literally put suspect's hair here, crime scene hair here, look at them at the exact same time and see how similar they are. It's a very good microscope for all forensic investigations because you can literally see them side by side, the suspects compared to the crime scene. Pretty important tool. I wish we could afford one. Fluorescence. So a fluorescent microscope is equipped with filters to detect fluorescent light, indicating the presence of dye or other treatment. So this is a very cool microscope to see if they have colored hair. The electron microscope provides incredible detail on the surface or interior of the sample, magnifying the object 50,000 times or more. So this whole thing is one big microscope, crazy expensive, very, very cool. And like the name suggests, electron microscope, it gets so in detail. Testing for substances in the hair shaft. So if we're moving past the microscope, there's some other things we can do to learn about a person's hair and match them in a crime scene. Because hair grows out of the skin, chemicals that the skin absorbs and some other toxins and drugs, which a person would ingest, can leave traces in their hair. So we can literally test poisons, drugs, things like that in a person's hair. In order to test the hair, it must be dissolved in an organic solvent that breaks down the keratin and releases any substances that might have been inside the hair. So a forensic chemist can then perform chemical tests for the presence of various substances to provide evidence of poisoning or drug use. So if we think the person OD'd, or we think the person was slowly poisoned to death, that evidence would be in their hair. So for drug testing, investigators can calculate the length of time during which a person was taking the drugs or a person was being poisoned, or ingesting other toxins by testing different parts of their hair. So this just kind of gives you a breakdown of drugs. Now, if you notice, the urine, the days really vary for all these types of drugs of getting out of the system through urine. But the hair test is the same. So our hair grows at a pretty steady pace. So in general, it's going to be in there for at least 90 days and then just continue to grow out. So it's not like it disappears. It's just for 90 days, you're going to have that drug still being added into your hair. Testing the hair follicle. So this is something that we'll look at in the lab as well. So if a hair is forcibly ripped out, so forcibly removed from the suspect or the victim, the entire hair follicle, the follicular tag, may be present. If so, blood and tissue attached to the follicle may be analyzed to blood type or to DNA. So usually hair you can't do this to, but if you have the follicular tag, so this, this little skin around the end of it, it's been forcibly removed, so there's tissue on it. So it's not necessarily that the hair has DNA, it's that the tissue that's attached to the hair could have DNA in it. Hair forcibly removed may also look stretched. So it's been pulled, yanked, and so it was stretched out. Naturally shed hair usually just looks nice and round, like that. DNA analysis of the hair provides, hair follicle provides identification with a high degree of confidence, whereas analysis of the hair shaft usually just provides class evidence. So saying if I only have the hair, just regular hair that's been naturally fallen out, then it's class evidence. If I have the follicular tag, it's been ripped out, then it could be individual evidence if there's enough to fold DNA. Hair is considered to be class if the follicle is present. Unless the follicle is present, the follicle contains DNA, which is considered individual. So I've said that like multiple times. Hopefully that is clear, that hair is usually class. But if I have the follicle, it could be individual evidence. All right, and that's it. For hair notes, fiber will be later.